Hi, in this session, I am going to discuss chi-square distribution. Chi-square distribution with k degrees of freedom, usually written as chi-square k, is a distribution which is obtained by adding the squares of k independent standard normal random variables. Chi-square distribution plays a pivotal role in data science since it is used in many non-parametric hypothesis tests and forms the basis for feature selection in classification tree technique chi-square automatic interaction detection or CID. In sentiment analysis, chi-square test of independence is used to identify the features that can be used to classify documents into various classes such as positive, negative or neutral. In logistic regression model, the chi-square test known as Wall's test is used to find the statistical significance of independent variable. Consider normal random variable x1 with mean mu1 and standard deviation sigma 1. Then we can write z1, the standard normal random variable, as z1 is x1 minus mu1 divided by sigma 1. Then we can square this function. So when we square z1 square, this will be x1 minus mu1 divided by sigma 1 square. So the z1 square is a chi-square distribution with 1 degree of freedom, and we write chi-square 1 to denote that. Let x2 be a normal random variable with mean mu2 and standard deviation sigma 2. Then we can define z2, which is a standard normal random variable. So let us look at another standard normal random variable z2, which is x2 minus mu2 divided by sigma 2. We again square this. So when we square your z2 square, is x2 minus mu2 divided by sigma 2 square. Now we are going to add z1 square and z2 square. z1 square plus z2 square. This is x1 minus mu1 divided by sigma 1 square plus x2 minus mu2 divided by sigma 2 square. This is a chi-square distribution with 2 degrees of freedom, and we can write this as chi-square 2. We can generalize this now. A chi-square distribution with k degrees of freedom is given by sum of squares of standard normal random variables z1, z2 up to zk, obtained by transforming the normal random variables x1 up to xk with mean values mu1, mu2 up to μk and the corresponding standard deviation values sigma 1, sigma 2 up to sigma k. That is, I can write in general chi-square k distribution, chi-square k. So here the k is the degrees of freedom. This is z1 square plus z2 square up to zk square, and it is nothing but x1 minus mu1 divided by sigma 1 square plus x2 minus mu2 divided by sigma 2 square up to xk minus mu k divided by sigma k square. So this is the chi-square k distribution. The probability density function of chi-square k is given in this slide. Here gamma k by 2 is the gamma function, where gamma function gamma k is nothing but integral 0 to infinity x to the power k minus 1 e to the power minus x dx. The probability density function of chi-square k with different values of k is shown in this particular figure. The cumulative distribution function of a chi-square distribution with k degrees of freedom is given by this formula. Here the small gamma k by 2 comma x by 2 is the lower incomplete gamma function. The lower incomplete gamma function, gamma k comma x, is integral 0 to infinity t to the power k minus 1 e raised to minus t dt. The cumulative chi-square distribution for different values of k is shown in this particular figure. In Microsoft Excel, the function chi-square dot dist within bracket x k true can be used for calculating the cumulative distribution function value of a chi-square distribution with k degrees of freedom. Let me go through a few properties of chi-square distribution. Chi-square distribution is a single parameter distribution in which k, which is the degrees of freedom, is the parameter. The mean and the standard deviation of a chi-square distribution are k and under root 2k respectively. As the degrees of freedom k increases, the probability density function of a chi-square distribution converges to a normal distribution. Chi-square goodness of fit test is one of the popular tests for checking whether a data set follows a specific probability distribution.